Good afternoon, boys and girls. I'm sorry for the bit of a delay. It was a traffic problem due to the closure of the road. Today we're going to do some stoichiometry calculations. So what I'm going to do first, I'm going to help you to distinguish between the different formulas, and then we can continue with all the formulas that we're going to do in the different calculations. So what we're first going to do is a little summary on mole. So if I look at mole, there's different ways of calculating mole. So there's the general one that you like most, and that is the one where you say n equals small m divided by capital M. And that is for all the phases. So I'm just going to write here for you, that is for all the phases. So it is for liquids, for gases, for everything. The n is mole, the small m is mass in grams, and the big M is molar mass in grams per mole. So let's just write in the units, it's grams and grams per mole, and it is in mole. But that is for all the phases. That is the general one that you're going to use the most. Then you get another one that you use just for solutions, and that is the concentration equals N divided by V. So N is measured in mole, V is measured in cubic decimeters, and C is measured in mole per cubic decimeters. So that is concentration. But now, let's make it a green one. Oh, let's circle this one in orange. There is the orange one for all. This greenie is only for solutions. So you can't use it to determine a solid, because that is only for solutions. So that means in brackets it will have an AQ. For all, it is solid, it is liquid, it is gas and aqua. All of them, as long as I must calculate mass. And then I have another one, but this one also has a specification that is only for gases. N equals V over Vm. So let's make this one a pink one. This pink one is only gases. So I can only use it when there is a gas present. Otherwise, I can't use it. N is in mole. V is in cubic decimeters. And Vm also in cubic decimeters per mole. Now, if you're in grade 10, the Vm has a constant value of 22,4 cubic decimeters. And that will be at STP. So that's my cubic decimeters per mole, because the definition says that 1 mole of all gases occupies a volume of 22,4 cubic decimeters at STP. That is now standard temperature and pressure. Now, if you're in grade 10, we're just going to use 22,4. In grade 11, it will be slightly different, but then we must give you the value. So let's say the temperature is 25 degrees. Maybe then Vm is going to be 24 and not 22,4. Or if the temperature is 40, maybe the value is 42 or something like that. But then we must give you the value. But if it's at STP for grade 10, then it is 22,4. So in grade 11, it can also be at STP. But the pink one is only now for gases. So I can't use it to determine a solution. I must only use it for gases. And then the other one, the last one, is also for all the phases, but that is where we count the particles. Now I'm going to write this one in a slightly different way that most kids understand more, and that is the amount of particles. The amount of particles. Okay, I'm just going to put the equal sign underneath, otherwise there's not enough space on my page. The amount of particles equals N, the amount of mole, Na Avogadro's number, and then the particles. Now, if I use the word particles in science, it can be many things. Particles can be electrons, it can be protons, it can be neutrons, it can be molecules, it can be atoms, it can be ions. So there's a lot of things in the word particles. So we're going to apply this formula a little bit later on. So this is for all particles. So let's make this also an orange one, because that is also for all the particles. So now we have the two opposite corners. You can use the two orange one for all particles, the pink one just for gases, and the green one just for solutions. So we're going to apply this page again, but that is the summary of all the mole formulas that you can use to get to the answers. Maybe in combination, sometimes you have to do more than one of these calculations to get to the answer. But we will get to that now when we apply it to the different calculations. So that is for mole. Okay, and the other thing that is important that we're also going to use here is where we have steps to solve the problems. Steps to solve problems. And that is very important from grade 10 to 12. If you just keep to these steps, then you can solve the problems. I don't know if it will solve your real life problems, but it will definitely solve your chemistry problems. Now the first step, you will see I'm going to go back to this every time. Step 1, you must write a balanced chemical equation. Balanced chemical equation. So if it is given to you, you're going to write it on your page again. Or you can write it on your exam paper, but you must start with a balanced chemical equation. Then step 2, you must look what is given and what is asked. So I must subtract the information so that I'm sure what is given and what is asked in this whole calculation. Because we like to give you a lot of words, which is sometimes unnecessary. So you must make sure that you just extract the given and the ask. Number 3, you must calculate mole of given. So you're going to calculate the mole of given. Then step 4, you're doing the mole ratio. And even if this ratio is 1 to 1, it counts a mark. And if it's not there, we can't give you a mark. So please make sure you're doing that calculation for us there. And then last step is calculate what is asked. Okay, now for grade 11, they come in excess and also for the grade 12s. So that will be here. Between step 3 and 4 will come in the excess, where we must determine the excess as well. So I'm just going to highlight that in pink, the excess, because it's still part of calculate the mole of given, but then I must first calculate the excess before we can do the mole ratio. So you must remember I selected the different exercises from the basics to grade 11. There's even grade 12 calculations also that we're not going to do this afternoon, but you can keep it for next year as well. You will see the document that I'm going to use. We will also make that available to you. Okay, so there's my steps that I'm going to use every time when we do the calculations. So I just want to fold my page a little bit smaller because we're going to use it a number of times now. Okay, so there's my little science script notes that I'm going to use. Okay, So let's see. There we have the first exercises that we're going to do. So I'm going to apply and also explain some further types of calculations that we have. Okay, if I look at a basic thing at the exercises, I'm going to start from basic to more difficult. So let's do number 1.1. I have there the question 6,4 grams of sulfur dioxide. So it's not part now of a question on a ratio type of stoichiometric question. I must just calculate how many moles of substance are represented by the given masses or volumes. Now, because the first one is a mass, I'm going to use N equals small m divided by capital M. Now, small m is the amount given, so that is 6,4. And the molar mass, I must calculate the molar mass of sulfur dioxide. So it's sulfur, di means 2, oxide means oxygen. So then I take sulfur is 32, if I read that from my periodic table, and 2 times 16 for oxygen. So if I'm working with my periodic table, then I take the relative atomic masses and add them together. So if I get this one, it's 64 grams per mole, and I put that into my value and I get 0,1 mole. Okay, so this is a small little calculation for you, but that is now just to explain how to use the formula, but you're going to use it as part of a bigger formula, or maybe in a multiple choice they can also ask a question like this. Okay, I'm going to continue to question 2. Calculate the empirical formula of each of the compounds which have the following percentage composition. Okay, now there's two things that you must be able to do. If I have my empirical formula, in plain English, that means I give percentages, you give the formula. If I have percentage composition, then I give the formula and you give percentage. We'll see it's just the opposite way around. So empirical formula, I give the percentages, you give the formula. Percentage composition, I give the formula and you give the percentages. Okay, so in this case, they ask empirical formula. So you will see there's a lot of percentages given. So there's the percentages given, there's the percentages given. So if you look at that, it's important. I give the percentages, you must determine the formula for me. And percentages, empirical formula, means the simplest way in which you can connect the different elements to each other. That doesn't mean it's necessarily a real formula. It can be, but it will be the smallest ratio where you can determine these elements together. So just make sure about that. So if I look at 2.1, the way to place the elements, you place them as from left to right on your periodic table. So you will see Al is in group 3 and you will find oxygen in group 6. So they're already in the correct order, so first Al and then oxygen. Now I like doing it in a table method. It is for me more organized, but you can decide how you want to do it. So I'm going to draw a table there and put them A, L and O into my table. So I organize them as from left to right on my periodic table. Next step, I'm going to calculate the amount of mole, because I can only, if I want to compare, I can only compare mole to mole. So I must first calculate mole there. Now, why do I do this? If I add those percentages together, 53 plus 47, gives me 100%. So that means out of 100%, 53 grams out of 100 grams gives me 53%, and 47 grams out of 100 grams gives me 47%. So that's why I can change the percentage into a gram. So I can say there 53 divided by. At this stage, I don't know if it's AL2 or AL3 or just AL. So I'm just going to divide it by 1 AL there, which is 27. Okay, I'll get my answer just now. So this one, I take the 47 and I divide it by 16. I don't know yet if it is O2 or O3 or O whatever there I must put in. So I'm going to say 53 divided by 27 and I get 1,96 mol. And I take 47 divided by 16 and I get 2,94 mol. So that was step 1. I determined the mole of each of the substances. Okay, so let's make a note here in a red pen. So I calculate mole of each. Okay, so that's my first step. I'm calculating the mole of each. And boys and girls, please, when you get to the stoichiometry, don't leave open spaces. If you can't do anything else, just calculate mole, and your teacher will be very happy. I tell that a lot to my kids. They even give me a coffee mug which says, just calculate mole. So you know how many times I tell them that in a year's time. So if you can't do anything else, just calculate mole. Okay, then the second step, you do a mole ratio. So I'm going to do mole ratio. So I'm going to take the values without the word mole and put them into a ratio, 1,96 to 2,94. So that is my mole ratio that I've done. Okay, then step 3 that I'm going to do, I'm going to divide by the smallest one. I'm going to divide by the smallest value. So in this case, 1,96 is the smallest value. So I'm going to divide, I'm just going to use a blue. The blue is my pencil. I'm going to divide by 1,96 on both sides. Okay, you don't have to show it, but I just want to show it to you now for the explanation's sake. So that means 1,96 divided by 1,96 gives me 1. And 2.94 divided by 1.96 gives me 1.5. I just want to put my lines in there. Okay. Now I have a problem because I can't have 1.5 oxygens. I must make a plan now. So if this value isn't a rounded number, I must make a plan. So now I can't round it to 2. I must get rid of the comma 5. Now comma 5 is the same as 2. It's 1 over 2. So what I'm going to do now, I'm going to multiply by 2 to get rid of the 0,5 because 0,5 is a half. And I'm timing it by the reciprocal because 1 over 2 times 2 over 1 gives me 1. So I'm going to multiply there with the reciprocal. So I'm going to multiply by 2. You will see on your calculator, if you press that SD button, I just want to show you, there's 1,5. There was 2,94 divided by 1,96. It gave me 1,5. And I press that SD button, it gives me 3 over 2. So to get rid of that 2 under the line, I multiply it by the reciprocal, which is 2. And I'm going to multiply this one by 2 as well. And then, so step 4, I must do the rounding. And then step 5 is my answer. Okay, so I get 2, 2, 3. And please, you can't round it from the top there and say, okay, but it also gives me 223. This is just a coincidence. It's not always rounding that number gives me the final answer. So my answer will be AL2O3, and that is my empirical formula. Okay, let's try another one. Let's do number 2.2. Okay, so we're going to use these steps again, just by applying it at number 2.2. Now you will see there's 3 elements, so I need 3 columns. So 2.2, let's draw some columns here. You don't have to do it in the columns, but I just like it. It's more organized to do it in columns than without columns, but that is your choice. Okay, now I have an O, a sodium and a carbon. If I look at my periodic table, I will see Na is in group 1, so I do it Na. Then C is in group 4 and O is in group 6. So I place it already here, but you can keep it in the same way as it is given, and then afterwards you can rearrange it, but I like rearranging it from the start. So I'm going to say N is small m divided by capital M. And do you see, boys and girls, I don't just divide numbers by each other every time. Formula, substitution, answer. So now I take the sodium, 43,4, and sodium is 23 on its own. Then I take carbon. Carbon is 11,3 divided by 12, and oxygen is 45,3 just divided by 116. I can't divide by 32 because I don't know yet if it's O2 or O3 or O4, whatever. So I just divide it by 1 there. So I'm busy calculating the mole of each. And you see I'm writing all down, and then I'm going to my calculator. So this first one gives me 1,89 mole. And then I get 0,94 mole, and I get 2,83 mole. So there I've done step 1. As on the previous page it said calculate the mole of each, so I've calculated the mole of each. Then the second step said I must do the mole ratio. So I take the values 1,89 to 0,94 to 2,83. So I put them into a ratio with each other. And then I'm going to divide by the smallest number. In this case it is 0,94. So I've divided there. Where's my blue pen? My blue pen is my pencil. I'm going to divide by 0,94 all of them. So I get 1,89 divided by 0,94, and I get 2. You will see I get 2,01, so it will be 2. I can only do the rounding when, let me write it down here for you. I can only do rounding for a 0,0 or a 0,9 or a 0,1. That's the only values that I'm going to round. All the other values you must multiply until you get an answer. So I can only round it for those numbers. Okay, so that's important for the rounding. So 2 and 1, and then I have 2,83 divided by 0,94, and I get an answer of 3,01, so it is 3. So in this case, I couldn't round that 89. I can't write it just round it just to 2. 9,4. If I rounded it, it was going to be 0,9, and I can't round a comma 8. So I first have to divide by the smallest and then round my answer. So if I get this final answer, it will be Na2CO3. And there's my empirical formula called sodium carbonate. Okay, so that is some empirical formulas. That's the smallest ratio that we have there. Okay, let's look at number 3. When I get to number 3, now they want the number of atoms, electrons, and ions. Okay, they ask for the first one, the potassium ions. I'm going to use this page again. So I'm busy now with this formula. It is just a rewriting of the formula. It just makes it easier for you to determine the amount of particles. So I'm going to apply this orange one. So I'm going to say now amount of, but remember I'm not going to say particles, I must specify now. It is potassium atoms, and that equals N times Na times potassium atoms. So you'll see the atoms, the particles part, and the particles part must be the same on both sides. So now I'm going to say, I must first determine the N. I don't have N yet. So I must determine for N, Na, it is 6,02 times 10 to the 23. Just make sure on your information sheet if it is given as 6,02 or just 6 times 10 to the 23. It can differ, so just make sure what that precise value is there. And how many potassium ions is there? If I look, it is K2SO4, so that means it will be K2, so that is 2. They don't say determine all the atoms, they say potassium atoms there. So I must just make sure they just talk about the K2. Okay, at this stage I don't have that value, so I'm going to calculate the value first. N is small m divided by capital M. So I'm going to say it is 2 grams, but when I use the formula, the molar mass, I must use the whole thing. Although it's just potassium atoms that I must calculate, I must use the whole potassium sulfate mass there. So it's 2 times 39 plus 32 times 4 times 16, which gives you 174 grams per mole. And then you say on your calculator 2 divided by 174, so it's 0,011. I write down the rounded number there, but please keep that whole number on your calculator. It's 0,01149 blah blah blah. So I keep the whole number on my calculator because I can't lose some particles. So I take that whole number on my calculator times 6.02 exponent 23 times 2. And now I can round my final answer 1,38 times 10 to the power of 22. That is how many particles it is. To explain it to you in other words is that if I ask you to buy me 1 dozen eggs, you're going to come back with a little box with 1 dozen eggs in it. How many eggs it is? It's going to be 12 eggs. Now a mole is like dozens of eggs. So if I want 3 dozen eggs, you must bring me 3 boxes of eggs there, but I need 36 eggs. So the mole is about the dozens of eggs, but the amount of particles is exactly how many eggs I have. So if I have 3 dozen, I have 36 eggs. Okay, 3.2. I must calculate now the electrons in 10 gram PbO2. So I'm going to say again now, must first calculate the mole. So it is 10 divided by capital M of PbO2. It is 207 plus 2 times 16 gives me 239 grams per mole. Okay, I get 10 divided by 239. And I get also, I'm going to write it as a rounded number, but I'm going to keep the whole number on my calculator. Okay, I'm trying to fit this in on one page. So I'm going to say the amount of ions, oh no, sorry, not ions, sorry, electrons equals N times Na times electrons. So it will be 0,042, 6,02 times 10 to the 23. Okay, now the problem is with the electrons. Where do I get the electrons? I'm going to use my pencil again. Okay, so if I look at Pb, and if I look at oxygen, and if I look at oxygen, it's about the amount of electrons. Now, if I look at the atomic number, you will see the atomic number of oxygen is 8 and 8. Now, that means there will be 8 protons, because that was meant by a number of the protons. The atomic number gives you the amount of protons, which is 8. But now, in this case, this is an ion, it's 2 negative. So if it's not an ion, if it's an atom, then it means the electron amount will be the same as the proton amount, which is then also 8. But now I gained 2 electrons, so it becomes 10. The same for this oxygen. It is now oxide. It's lead oxide, so it's 2 minus. So the protons will be 8, but it gained 2 electrons, so that makes it 10. Okay, and if I look at lead that I have there, I have lead is 80. So that means these protons will be 80, but lead in this case, no, sorry, it's 82. Lead is 4 plus in this case, so it lost 4 electrons. So this means the electrons will be 78. So now if I add my electrons together, I will get a 78, a 10 and a 10. So 78 plus 10 is 88 plus 10 is 98. Okay, I'm going to write the answer for you here. So now I calculated the amount of electrons. So the amount of electrons will be equal to the amount of protons if it is an atom, if it's an element. But now in this case it is an electron, so an ion, so it lost or gained electrons. So that means there I've calculated the amount of electrons. So it will be that 10 divided by 239 was a rounded number there, but I kept the whole number on my calculator, times 6.02 times 10 to the 23 times 98, and I get 2,47 times 10 to the 24. Please, with chemistry, it is very, very important just to round the final answer. Because if you round too soon, you will get a different answer in the end. So just make sure you don't lose your particles. So there I've written down a rounded number, but I kept the whole number on my calculator. And then I went on and determining the amount of electrons in this case. Okay, that was counting the particles. So what I'm now going to do, now we're going to do some stoichiometry calculations where we need our 5 steps. Just want to get my little page again. So I need my 5 steps to get to my answer. Okay, let's look at question number 5. there on your page, there is a question number 5. Question number 5 says balance the following equation. So they didn't give you a balanced chemical equation. So when you remember back, I'm busy now with this balanced chemical equation. That is my first step that I must do. I'm going to number the steps for you, then you can see how I'm applying these steps. Okay, so I'm going to do now number 5. So I must first write down a balanced chemical equation. So I'm going to copy it. Zn plus HCl gives me ZnCl2 plus H2. Okay, so now if I look, H, there's one H on the left-hand side, there's two H's on the right-hand side. So I'm going to put a 2 in front of the H. So 2 times H and 2 times H is the same on both sides. 2 times Cl and 2 times Cl, the same on both sides. And then 1 Zn and 1 Zn, that gives you the final answer. Okay, so I've done step 1, because step 1 says write down a balanced chemical equation. Okay, so there's my step. I've done balanced chemical equation. Now step 2, look what is given and what is asked. So let's do step 2. Step 2 say, calculate the mass of zinc. Okay, I'm going to stop there. So that is ask. So I'm going to make M with a question mark, that is ask. Calculate the mass of zinc needed to release enough hydrogen from HCl to fill a container of 100 cubic decimeters at STP. Okay, it's not about the HCl, that is hydrochloric acid. What is the gas? Release enough hydrogen. Hydrogen is a gas. And if you want to fill a container, a gas fills the whole container. So what do they actually tell you? They tell you that H2 is 100 cubic decimeters. That's the volume. And you will see they specify it, it is at STP. And why do they do that? So that I can be able to use that 22,4 part there. That is why they do it. Okay, so I've done step 2. Look what is given, that is given, and what is asked, that is asked. Okay, step 3, calculate the mole of given. Right, so step 3, hydrogen gas is given, so I'm going to calculate the mole. If you like to, you can calculate it here underneath, and then I like saying to myself, okay, what volume I'm busy calculating, what mole I'm busy calculating. So I like writing that H2 there, that I'm sure I can tell my teacher that's what I'm busy doing. But you don't have to write that H2 there. It's my preference, I like to write it there to make sure that the marker knows what I'm busy with. It is already in cubic decimeters, so that's 100. Vm, that's a constant you read from your information sheet, 22,4. I just want to show you something else. Milliliter is the same as cubic centimeters. So that is, a milliliter is the more common one that we know about. But scientifically, everything must be in meters, so we called it cm to the power of 3. Cubic centimeters or centimeters cubed. And then you get liter. Liter is the same as cubic decimeters. Now, somewhere in the primary school, they already told you to get from milliliter to liter, you must divide by 1,000. So if you know that, it is easy to get from cubic centimeters to cubic decimeters is the same, you must divide by 1,000. Because your values must be in cubic decimeters to, for the units to cancel so that I can just get mole. So I must now say I have 100 divided by 22,4 and my answer will be 4,46 mole. And again, it is a rounded number. So I keep the whole number on my calculator until this calculation is finished. So I haven't finished my calculation yet. Okay, now I'm at step 4. So let's refresh now. Step 4 says mole ratio. Now the mole ratio means I must take the balancing numbers. The balancing numbers gives me the amount of moles that I have. So what I'm busy using, I'm using zinc and H2. I don't want the other ones now. Maybe later on there's another part of the question, but I just want the zinc and the H2. So I'm going to say zinc to H2, and the ratio is in front of the zinc, there's a 1. If there stands nothing, it's a 1. And hydrogen, it's also a 1. So that means hydrogen is 4,46 moles that I just got there. I'm just going to make you an arrow. You don't have to make an arrow. And then the ratio is 1 to 1, so that means this value is exactly the same. And then step 5. Step 5 says calculate what is asked. And what did they ask? The mass of zinc. So now if I have all my formulas in mind, I must keep this, use this one, N equals small m divided by capital M. I do have the mole, 4,46. M, I want to calculate the small one. The big one I don't have to calculate here on the right hand side because it's only zinc and that is 65. So I take that number still on my calculator and multiply it by 65 and my answer is 219,18 grams. So I'm sticking the whole time to these steps. I'm getting a balanced chemical equation, look what is given and ask, calculate the mole of given, do the mole ratio, calculate what is asked. So I keep doing the same thing over and over again. Okay, boys and girls, I'm going to use the steps now again and doing one with the excess, so that one with the little pink stripe, but I'm going to use the same steps again. So if you look there on your screen, I'm going to do number 6 there. Okay, number 6. What is my first step? Okay, you don't have to number the steps. It's now just for the exercise. That's why I'm busy numbering my steps. So I'm going to do it again, but you don't have to do it in an exam. Okay, so step 1, write down a balanced chemical equation. Okay, nice. In this one, it's already balanced. So I don't have to do anything. It's already balanced. Step 2, I must see what is given and what is asked. Okay, let's try this one. Look what is given and what is asked. So what is given and asked? Calculate which one of the two substances will be used up. Okay, used up means that is the one that is not in excess. Excess means I've thrown in too much of it. If it is in excess, there's too much, so they will be left afterwards. If it's used up, we call it a limiting reagent. So I want to know which one is the limiting reagent. So I don't know which one, but that is my question. I want a limiting reagent. Now they say, calculate which one of the two substances will be used up if 20 grams of iron and 10 grams of sulfur are mixed and heated. Okay, now important. If they give you both reagents, the things on the left-hand side is the reagents, and the things on the right-hand side of the arrow, that's your products. Now, if they give you the things on the left-hand side, and they give you both of them, you must know one is in excess. So I'm going to write myself, because I used it in pink, I'm going to say there's an excess. So somewhere there's an excess. Step 3. So I'm just keeping to my steps. Do you see? There's my steps, balance chemical equation, look what is given and ask, calculate the mole of given. So I'm there now, and then I'm going to do excess. So step 3, calculate the mole of given. But now there's 2 givens. Okay, that's no problem, then I work out the mole twice. So I'm going to say N, and now I like writing there because I'm going to do the same thing twice, so let's make sure I know which one I'm busy with. There's the iron. M, it's 20, divided by iron is 56. And I'm going to do the same for the sulfur. N of sulfur equals small m divided by capital M. It's 10 grams, and that is 32. So now I'm going to my calculator and say 20 divided by 56, which gives me 0.36 mole. So you see, I don't leave everything in a ratio form. You must give an answer because they say round to 2 digits after the comma, 2 decimal places. 10 divided by 32, so I don't keep it as a fraction of whatever they give me. The fraction was 5/16, so I don't keep it like that. I round it to 2 decimal places, 2 digits after the comma. Okay, so now I've done step 1, balance chemical equation. Step 2, what is given and asked. Step 3, I've calculated the mole of given, but because there's 2 givens, I've calculated twice. Okay, now on that little page of mine, you will see calculate the mole of given, and now I must first do the excess before I do the mole ratio. Okay, now if I look at this one, I see Fe to S, and the mole ratio is 1 to 1. So that means they are supposed to be the same. But now I see they're not the same. The iron is slightly bigger, 36, so it's 36 and that one is 31. If I don't take the 0 comma in account, this one is 36 and that one is 31. So that means I've put in a little bit too much of iron. So that means they must supposed to be both the smaller one of the two, 0.31. So that means the iron is in excess. But the question asks, calculate which of the 2 substances will be used up. So they ask the limiting reagent. So sulfur is the limiting reagent. Sulfur is the limiting reagent. So the iron is in excess and the sulfur is the limiting reagent. So that means S will be used up. If I answer the question, it will be used up. Okay, now they ask you 6.2. How many grams of the other substance were in excess? So I know that the iron is in excess. Okay, there's different ways to do 6.2. I can do it, the one way is by saying at 6.2, I can say, let's calculate the amount in excess mole. So that's the amount in the beginning minus the amount that I use. So that means in the beginning I had 0.36. I was just supposed to use 0.31. So 0.05 mole was left. I use the rounded numbers now because I'm busy now doing the next calculation. So if it's still part of the first one, then I don't round, but this is now 6.2, so I use the rounded numbers. And then I say N equals small m divided by capital M. I'm busy with the iron, so it's 0.05 m, and this is 56. So that means 2,8 gram is in excess. Because they asked the amount of grams in excess. So that is the amount that we used up. Okay, boys and girls, we're going to take a small break and then I will see you at 15:15 again. Hello boys and girls, we are back after the short break. So I'm going to do another one where we use some excess and impurities as well as the volume determination now. So I'm going to do a little bit more difficult calculations for the grade 11s. So let's continue on this section. I'm busy now with number 10. An excess of diluted sulfuric acid reacts with 20 gram of impure iron. Okay, if they say it is impure iron, I don't know what is the impurities. So please make sure there, whatever that impurity is, it didn't react with the H2SO4. But now I must leave that 20 gram. I'm not going to do anything. I'm going to ignore it now. In a reaction which occurs, 5,6 cubic decimeters of dry hydrogen gas. Dry hydrogen gas means it only contains hydrogen gas and no water, is liberated at STP, calculate the percentage purity of the iron. Okay, so I'm going to start again by writing down my balanced chemical equation. So you see, every time, although it is given, I'm writing it on my page. I'm writing my balanced chemical equation. Okay, what is given and what is asked? They ask the percentage purity. Okay, now if I want to determine percentage purity, I must divide a mass by a mass. So what do they actually ask me? They ask the mass of the pure iron, because that is how I determine the mass of the iron, because whatever the impurity is, it didn't react. And they say I have 5,6 cubic decimeters at STP of hydrogen gas. So there's no water present. So I'm looking for the mass of the pure iron. So that is what I want, because I want percentage purity in the end. So I'm just going to write you here at the bottom of the page, if we want percentage purity, it means you must take the pure mass divided by the impure mass times 100/1. So that is your formula that you need. So I don't have the pure mass at this stage. I have the impure mass times 100/1. So the whole thing about this calculation, I want the pure mass. So I'm looking for this value that I must put on the top, because if I have that value divided by 20 times 100, then I get the answer. But I must first get this value. So that is now the purpose of the top calculation. Okay, we will get to that one again. So that is why I made mass unknown. I'm looking for the mass of the pure iron. That is the purpose of this whole experiment. Okay, there's step 1, there's step 2. Step 3 says I must calculate the mole of given. And hydrogen is a gas, so I can use my formula V over Vm because it's a gas. And it's already in cubic decimeters, so it's 5,6 divided by 22,4. So I take 5.6 divided by 22.4 and I get 0,25 mole. So there I've determined the amount of mole of hydrogen. So I can only compare mole to mole. Then the next step is mole ratio. So I'm going to do iron to hydrogen, and the mole ratio again in this case is 1:1. And it's 0,25 for hydrogen. I got it from there. So that means the iron is also 0,25 moles. And then I must just determine the mass. So the N of iron equals small m divided by capital M. and 0.25, and the molar mass of iron is 56. So I take that number on my calculator, multiply by 56, so I get 14 grams. And please just make sure if you calculate percentage purity, it can't be more than 100. So if you swap the two values, then you will see you've got a problem. So I'm going to take 14 divided by 20 times 100, and that gives me 70%. So this is a 70% pure substance. So somewhere there's a 30% impurity, but I don't know what it is, because whatever it is, it didn't react. Most of the time it is sulfur, but sulfur doesn't react with any of your acids. So that is why it's not part of the reaction that is given. So 70% purity that we have. If I'm calculating a percentage, I times it by 100/1. Okay, let's look at question number 11. If I'm looking at question 11, okay, you will see on your page, it is this one. Now they say, in the Haber process, 5,000 cubic decimeters of nitrogen gas reacts completely with 17,000 cubic decimeters of hydrogen gas. Calculate the total volume of all the gases after the reaction is completed, assuming that the volumes of all gases have been measured at the same temperature and pressure. Okay, now they say we must first write a balanced chemical equation. Now this is the first one where they didn't give the equation, so that makes it a little bit more difficult. So now it's more on the grade 11 level, but grade 10s can also do this question. We must just give them the formula. Okay, nitrogen. If it's nitrogen gas, it is N2. It reacts with hydrogen, H2. It's not necessary now to put in the phases, but if you like to, you can put a G in brackets for gas. Now, if you compare nitrogen and hydrogen, the answer is ammonia, NH3. So nitrogen gas and hydrogen gas gives you ammonia. Okay, now you must make sure we must balance the equation. Let's start with the hydrogen. There's 3 on the right-hand side, 2 on the left-hand side. So that means I must multiply by 3 on the left-hand side. 3 times 2 is 6. But then I must do on the right-hand side a 2. 2 times 3 is 6. So that means 6 hydrogens right, 6 hydrogens left. Nitrogen, there's 2 nitrogens left. And my problem was solved. There's 2 nitrogens on the right-hand side. So there I've started with my balanced chemical equation. Okay, that's step 1. Step 2, what is given and what is asked. In the Haber process, 5,000 cubic decimeters of nitrogen gas reacts completely with 17,000 cubic decimeters of hydrogen gas. Calculate the total volume of all the gases after the reaction. So they want V total after the reaction. Okay, if you want to, you can put in there it's a gas, and ammonia is also a gas. So now this means in this reaction, nitrogen is used up, hydrogen is used to form ammonia. Okay, so there will be ammonia, but now your hair must stood on end because both reagents are given. So that means one will be in excess. So that's very important. So one of them will be used up. Of one of the two, there will be something left, and it's not always the biggest one of the two. And then you will form ammonia. So we must find out what is the volume of the ammonia formed. Now the other important thing is written there. Calculate the total volume of all the gases after the reaction is completed. Assuming that the volumes of all gases have been measured at the same temperature and pressure. But remember, that doesn't mean STP. They just told me the same temperature and pressure. So it can be 25 degrees Celsius and 200 kilopascals, or it can be 30 degrees Celsius and 150 kilopascals or whatever, but they didn't say STP. So I'm not allowed to use 22,4 now because it is not STP. So please remember that is very important. So what I'm going to do, I'm going to say N equals V over Vm. Now Vm is a constant value at a certain temperature and pressure. So that means if I rearrange this, the amount, the mole is directly proportional to the volume. So that tells you that the mole ratio, the word ratio, the mole ratio is directly proportional to the volume ratio. So I don't say now that the mole is directly proportional to the volume. The ratios are proportional to each other, so I don't say they equal to each other. So that means if I look at the ratios, if I look at N2 to H2, that means they must be in the ratio 1, which is in front of the N2, and 3, which is in front of the hydrogen. They're in the ratio 1 to 3. Okay, I'm going to take the one that's standing first. That's the nitrogen. That means 5,000. So let's make the hydrogen unknown. So that means if I work this out, I'm using my blue pen as my pencil. I take this 5,000, I multiply it always with the one furthest away, and I divide it by the one on top. So I take 5,000 times 3, which is 15,000, divided by 1, so I get 15,000 cubic decimeters. Okay, how much did I put in? Oops, I put in 17,000. So that means my hydrogen is in excess. So I've put in too much hydrogen in this case. The hydrogen is in excess. Okay, now I must work out what is the volume of the ammonia formed in this case. You work with the limiting reagent. So I must take the N2 to NH3, and the ratio is in front of the N2 is a 1, in front of the NH3 there's a 2. So that means it's 5,000 cubic decimeters. I take the 5, multiply it by 2, divided by 1, so this gives me 10,000 cubic decimeters. I still haven't answered the question because they say calculate the total volume of all the gases after the reaction. So now I'm going to say the volume of N2, the volume of H2, the volume of NH3, and that gives me the total volume afterwards because there's all the gases. Because N2 is the limiting reagent, I have 0 of that left. That is my limiting reagent. Okay, the H2. I put in 17,000 initially. I was just supposed to use 15,000. So how much is left? 2,000. And please, boys and girls, every calculation, that is an easy one. You can even do it without a calculator, but you must show everything to us. So you see, I've put in there how did I arrive to my answer? 2,000. Initially, I had 0 NH3, but I formed 10,000 cubic decimeters. So 0 plus 2,000 plus 10,000 gives me 12,000 cubic decimeters. And there I've answered my question. I got to the total volume of all the gases after the reaction. So please remember, in this case you can't use the 22,4 because of, they say the same temperature and pressure, but they didn't specify STP. They just say same temperature and pressure. So just make sure about that. So I started by saying, okay, but Vm is constant. It doesn't matter what the value is, it is a constant value. So that means that my mole ratio is directly proportional to my volume ratio. I didn't say the mole equals the volume, I said the mole ratio equals the volume ratio. So then I can use the ratios and say N2 to H2. I just took the nitrogen because it was standing first. So my N2 is 5,000 times 3 in front of the hydrogen divided by 1 gives me 15,000. So H2 is in excess. Then N2 to NH3, I took the N2 now, the limiting reagent. I worked out the amount of NH3, which is 10,000, so that is formed. And then I added them together. So just make sure I'm just using all the gases now in my reaction. If one of them were a solid, then it means I don't use that one because it is a solid. Okay, now let's look at some other questions as well. I copied this from old exam papers. You will see there the first part I set up this which says exam questions is what I copied from old exam papers. Okay, so we can use exactly the same questions for grade 10 and 11, but for grade 11s we just give less information than for grade 10s, and then it makes it a little bit more difficult. Okay, so let's look at the exam question part that we're going to do now. Okay, they say, the airbags in motor vehicles contain the compound sodium azide. When a car crashes into an object, the compound decomposes and the nitrogen inflates the airbag. The balanced equation for the reaction is as follows. So that means that is inside the airbag, and when this airbag explodes, it forms Na and N2, and that N2 gas blows up the airbag so that you don't get too bruised in this accident. Okay, so that is supposed to help you not to hit your head on the front windscreen and keep you safe. Okay, now they say the balanced chemical equation. So let's start again and say we're using the balanced chemical equation. So 2NaN3 gives me 2Na plus 3N2. So I'm starting again, balanced chemical equation. What is given and what is asked? They say in one such decomposition, 2,53 times 10 to the power of 8 molecules of nitrogen are generated. So this is nitrogen N2. So they say 2,53 times 10 to the power of 8 molecules are generated. So that's given. What is asked? The number of moles of NaN3. So I'm just doing the same thing over and over again. So I'm keeping to my steps that I have, and my steps told me I must do a balanced chemical equation. So I've done my balanced chemical equation. Balanced chemical equation, what is given and what is asked. Now I must calculate the amount of mole. Okay, if I take you back to that first page I did this afternoon, if I look at mole, at this stage I can't say any small m divided by capital M because I don't have the mass inside that airbag. I can't use the volume because I don't know what is the volume, and it's definitely not at STP because standard temperature is 0 degrees Celsius. Okay, maybe if it's winter in Bloemfontein it's possible, but they didn't tell me that. What did they give me? They've given me the amount of particles. So I must do this orange one. The amount of particles, N times Na times particles. So I'm going to use that formula there. So I'm going to say the amount of, and instead of the word particles, I'm writing molecules equals N times Na times molecules. Okay. I don't know what is N that I want to calculate. What is the amount of molecules that was given? 2,53 times 10 to the power of 8. So that was given today. Usually we work out the left-hand side, but in this case it was given. And Na 6,02 times 10 to the 23. Okay, and N2 is 1 molecule. You will see that 3, that ratio, I will take into consideration later on when N2 and Na3, when I compare them. But if I just look at the N2, N2 is 1 molecule containing 2 atoms, but it's 1 molecule. So I'm going to say 2.53 times 10 to the power of 8 divided by 0,2 times 10 to the power of 23, and I get 4,202 times 10 to the negative 16 mole. So that is a very big number there, but I'm just keeping it on my calculator. You can also do it like this to say you haven't rounded it yet, you're still busy doing your calculation. But they ask me the amount of mole. So now I've calculated mole, that's step 3. Step 4 is I must do the mole ratio. So I'm busy doing the mole ratio there. So NaN3, there's a 2 in front. N2, there's a 3 in front. So I've calculated N2, 4,2 times 10 to the negative 16 mole. I'm just going to use my pencil again. That value, I must times it by the one furthest away, and I must divide it by the one on top. So that means on my calculator, I take 4,2, I multiply it by 2 and divided it by 3. So this answer is 2,802 times 10 to the negative 16 mole, of just then 2,8 times 10 to the negative 16. They just asked me, this was 1.1. They just asked me the amount of mole. So I don't have to do anything else because they just asked the number of moles. Okay, now number 1.2, they asked the volume of N2 produced. Now N2, I've already calculated the amount of mole of N2. Just put it in there, then I don't have to wonder. That is the amount of N2. So I can just say N equals V over Vm. I do have the mole, 4,2 times 10 to the negative 16. I don't have the volume, but they say assume that the reaction occurs at standard pressure. So now I can use my 22,4. I can use now a rounded 4,2 here because it was the answer of the previous calculation. So I can just use 4.2 times 10 to the negative 16 times 22.4, and my answer is 9,41 times 10 to the negative 15 cubic decimeters. Okay, so I've done number 1.1 and 1.2. Okay, boys and girls, I'm first going to do the uneven numbers now, so I'm going to skip to number 3 now. Let's just find number 3. There's question 3. Okay, question 3. The fish produced when an ant dissolved in water is caused by the reaction between sodium hydrogen carbonate. In plain English we call that enos. So that's sodium hydrogen carbonate, that is commonly known as INOS. And citric acid. There's the formula of the citric acid. The balanced equation for this reaction is that. Okay, please don't get a fright because it is bigger molecular formulas now. Just go through the motion. It is still a carbonate plus an acid gives you a salt plus carbon dioxide plus water. So it's the same thing that you were taught in grade 9, that a metal carbonate plus an acid gives you salt plus carbon dioxide plus water. Okay, 3.1. Write down the formula of the substance that causes the fizz when it's dissolved in water. So that means they ask the formula, so I must write down CO2. Please be cautious if they ask you write down the name, then you must write carbon dioxide. If they ask the formula, then you write CO2. So just make sure. So anything that makes a fizzy whatever. So if you put ACC into water, there's a carbonate that causes that CO2 gas. If you look at Barocca, put that into water, it makes a fizzy sound. So that is the CO2 that is released. Okay, 3.2, that's a definition. So please don't just write for your teacher definition or see exam guidelines or something like that. You must know that definition. And please make sure definitions 2 marks or 0. So you must make sure you know your definitions. Okay, 3.2. Now they say a certain antacid contains 1,8 grams of citric acid and 3,36 grams of INOS. The acid is dissolved in 100 cubic centimeters distilled water in a beaker. Calculate the number of moles of NaHCO3. I'm going to stick to that recipe. I'm first going to write that formula again. Just make sure this one is big, that you rewrite it correctly. Six. Okay, a little bit off the page. There it is. Okay. I've written that whole formula. I just want to shift it back again so you can see the question. Now they say it contains 1,8 grams and 3,36 grams. Here must stood on end immediately because both reagents are given. So make sure both reagents are given. So one will be in excess. Okay, they say it is dissolved in 100 cubic centimeters distilled water in a beaker. Okay, calculate the number of moles of NaHCO3 in the acid. Okay, so I'm going to do 3.3. So I'm going to say N equals small m divided by capital M. 3,36. I must calculate capital M. And just make a note, it is without the 3 in front. The 3 is only there for the mole ratio. It doesn't mean the mass is now going to be 3 times bigger. Okay, Na is 23, plus H is 1, plus C, it's 12, plus oxygen is 3 times 16. So I read the values from my periodic table, and I get 84 grams per mole. Okay, and I say 3.36 divided by 84, and I get 0,04 mole. Okay, that was for 3 marks. So if it's 3 marks, it is your formula substitution answer, and that is your 3 marks. Okay, 3.4. Determine using calculations which substance is the limiting reagent. Okay, boys and girls, what they're busy doing now in question 3 is they divided it into smaller little parts. So this can be given for the grade 10s as well as the grade 11s. So they cut it into small little parts. Maybe for the grade 11s, They won't say 3.3, 3.4 and 3.5. They will just say 3.5 and give the 10 marks. Calculate the mass of the reactant in excess and they will say it counts 8 or 10 marks. But now, because you lead, it makes it a little bit more easy from a type 3 question to a type 2 or from a 4 to a 2. So now they say in steps what you must do. So this one will be fit for both the grade 10s and the grade 11s. Okay, let's look at question 3.4. They ask 3.4, determine using calculations which substance is the limiting reagent. Okay, in this case, I've already calculated the amount of mole. I'm just going to write it here, NaHCO3. I've already calculated that as 0.04 mole in the previous calculation. So I'm just rewriting it there because we don't have it on the screen now. Okay, so what I must do now, I must calculate the acid, the citric acid. I'm just going to make an A for acid there. I'm calculating small m divided by capital M because the mass was given, and that was given as 1,8. So now I must calculate capital M. So now just make sure you rewrite correctly. H3, C6, H5O7. Rewrite it correctly. So it's 3 times 1 plus 6 times 12 plus 5 times 1 plus 7 times 16. So just make sure everything is there correct and written down. And I got there 192 grams per mole. So I take 1.8 divided by 192 and my answer. Okay, if there is more than one digit after the comma, please then write it scientifically. Okay, so now I just want to cover this. If you have your calculator, it's given a value like that. So please write it scientifically. But you don't have to count or anything. Your calculator is very clever. You just push Shift, Setup. Now you see there's a selection there. And you choose 7 because it is scientific. Now it gives you that range there. Now you say 3 because you want one digit before the comma and 2 after the comma. So it already rounds it for you. Do you see? There it is, already rounded for you nicely. So I'm just going to show it to you again. So that was initially the value given. So I'm going to say Shift, Setup, 7 for scientific, and then 3 because I need one digit before the comma and 2 after. If you want to get it away, you don't want that SCI scientific anymore on your screen, you say Shift, Setup, 8 is normal, and then you choose 2. So the uneven numbers goes together, the 7 and the 3, and the even numbers goes together, the 8 and the 2. So I'm just going to put it in again. There it is. So I'm going to write 9,38 times 10 to the negative 3 mole. So if there's more than 1 0 after the comma, please write it in scientific notation. Okay, so now let's see. Now I must do a mole ratio because I've worked out the mole of both. So let's do a mole ratio. I'm going to say the mole of NaHCO3 to the acid which is HC6H5O7. The mole ratio is in front of this one, there's a 3, and in front of this one there's a 1. Okay, now NaH is standing first, so let's take that 0,04 mole value. I'm using the one that's standing first and I see what will happen. So now I take the 0.04, I times it by 1 and I divide it by 3. So I took this value times 1 divided by 3. Okay, and I get my answer as 0,013 mol. But now I see it is more than I have, because this is 0,13, that is 13, if I round it, and that one is 9. So that means I made the wrong assumption. So I'm going to do this calculation again. I don't Tipp-Ex it out, I don't scratch it out, I just draw a line exactly like this through it. So I'm going to redo this one again. Okay, if I look at this one, it is 9,38 times 10 to the negative 3 mol. So I take 9.38 times 10 to the negative 3 mol. I times it by 3 and I divide by 1. So that means I take this one, multiply by 3, divide by 1, and then I get the answer of 0,028 mol. So that means if I round it, I put in 40 moles and I only needed 28 moles. So if I make it a little bigger for you to understand, I put in 40 moles, but I just needed 28 moles for the answer. Okay, so that means determine using calculations which substance is the limiting reagent. So therefore, you can write it, citric acid is the limiting reagent, or you can write out that whole formula again if you just make sure that you write it down correctly. You can write that whole formula again. So citric acid is the limiting reagent because the question asks, determine using calculations which substance is the limiting reagent. So I tried that one, it didn't work, so I tried a new one. Okay, now the next one, 3.5, calculate the mass of the reactant in excess. So NaHCO3 is now in excess. So I'm first going to calculate the mole in excess. So I'm going to take the mole in the beginning minus the mole used. Now in the beginning, the NaHCO3 is in excess. So that means in the beginning, I had 0,04 mole. That comes from 3.3, minus 0,028 gives me 0,012 mole. So that's 0.04 minus 0.028 gives me 0,012 mole. But they asked the mass in excess, so I'm going to say N equals small m divided by capital M. The 0,012. Okay, now that in 3.3, I've already calculated the molar mass, so I'm not going to do it again. So that 84 comes from 3.3. I'm just going to write it here for you in my blue pen, in my pencil. It comes from 3.3. So that means 0,012. I'm going to multiply it by 84 and I get 1,01 grams. So that means from that 3,36 that I put in initially, more or less 1 gram is in excess. Okay, 3.6. This is now a little bit a more difficult question because they don't tell you directly what you must work out. You must know what you must work out here. They say, calculate the mass decrease of the beaker contents on completion of the reaction. Now, what made the mass of the beaker decreases? If I look at that total reaction there, the AQ is dissolved in that water. But what happened to the CO2? It made a fizzy sound and that left the beaker. So the decrease in the beaker is caused by the CO2 that left the beaker. And they asked, calculate the mass decrease of the beaker contents on completion of the reaction. So that mass decrease of the beaker, that is the mass of the CO2. So they actually asked the mass of the CO2 because the mass decrease of the beaker. So I'm going to say N equals small m divided by capital M because I need that. But in this stage, I must still work out the CO2, and that will be 12 plus 2 times 16, and that gives me 44 grams per mole. So I already know that 44 grams per mole there. Okay, what is the other thing that I must know? I must know the mole ratio that I have. So I must work with the substance that is not in excess. So now I'm going to do a mole ratio. I'm just going to do it here to the right hand side. The substance that's not in excess is that citric acid to the CO2. Now the mole ratio, if I look in front of the citric acid, there's 1, and in front of the CO2, there's a 3. So that's my mole ratio that I'm determining. So now I've worked out this as 9,38 times 10 to the negative 3 mole. I'm just going to get that on my calculator again. I must multiply it by 3 and divide it by 1. So this is 0,028 moles. I must calculate small m, so I take that 0,02814 times 44, and my answer is 1,24 grams. Okay, so I worked, so the CO2 that left the beaker made the beaker lighter. It made a decrease in the mass of the beaker. So that was difficult now to determine that. So the CO2 gas that left the beaker made a decrease in the mass of the beaker. So I took the one that is the limiting reagent to the CO2. I did the mole ratio. And then N is small m divided by capital M. The N I do have, capital M is 44, and then the mass is 1,24 grams. So that means your beaker will be 1,24 grams lighter. It is the same reaction when you drink Coke or Fanta or Sprite. When you open that cap and it makes psh, that psh sound is where the CO2 leaves the beaker, the bottle. So the bottle will also be lighter afterwards. Okay, it will also be lighter because you're going to drink some of the cool drink. But just before you drink the cool drink and you measure it again, you will see it is a little bit lighter because of the CO2 that left the cool drink. Okay, boys and girls, let's look at another calculation. Now you will see we have number 5 here, and that is the one with the graph. Okay, now usually you get scared when you see a graph. Please don't do that. Just use your graph, because the graph can give a lot of information. But the important thing is when you go there, highlight or circle or whatever you want to do, just draw your own attention to what is written on the axis. So that is very important. So make sure in this case it is about the volume of the CO2 and the mass of the CaCO3. So make sure you know what is written on the axis, as well as the value, cubic centimeters and grams. So make sure, so draw a circle around it, draw it in a red pen, whatever, just make sure your attention will be there. Okay, so let's look at question number 5. So stoichiometry for grade 10 and 11 is more or less the same. It's just the way we ask the questions that make it a little bit more difficult, as well as a little bit that comes by, it's extra added in grade 11. But the principle stays the same. Okay, question 5. Calcium carbonate, CaCO3, reacts with diluted hydrochloric acid according to the following balanced equation. So you can see they start with a balanced chemical equation. So I like writing down on my page my balanced chemical equation. Just make sure you rewrite correctly. Okay, there's my balanced chemical equation. The above reaction is an example of an acid-base reaction. Define the term acid-base reaction. Okay, so 5.1, they start with a definition again. So you must make sure you know your definitions. This is already a reaction also in grade 9, where you have a metal carbonate plus an acid gives you a salt plus water plus carbon dioxide. Okay. 5.2. The graph below shows the relationship between the volume of carbon dioxide gas formed and the mass of pure. That is very important. They say it is pure calcium carbonate. Okay, so volume, mass. From the graph, determine the volume of CO2 produced when 0,072 grams of pure CaCO3 reacted. Okay, now how must I do that? I must see 0,072. Okay, so I draw a line there, 0,072, and then I must just trace it back to the other axis, and that's how I get the answer. So this one will be 0,072 there, and draw a line to that side, which will give you 18 if you read it from the graph. So I draw a line from the axis to the graph, and then from the graph to my left-hand side, and I get the answer. And please remember your unit. 5.3. A certain antacid tablet with a mass of 0,25 gram contains mainly calcium carbonate. Please remember, it doesn't say this whole tablet is calcium carbonate. It says it contains mainly. So that's important. It's not consist of, it contains. Mainly calcium carbonate, which reacts with diluted hydrochloric acid in the stomach to produce carbon dioxide gas. The concentration of hydrochloric acid in the stomach is 0,1. Okay, so that concentration, so this value is C, and there's a value of M, the mass. 5.3.1, define the term concentration. Now concentration is N divided by V. But if they say define, it means you must give it in words. So define means you must give it in words, please. 5.3.2. So you can see there's already 4 marks for definitions. 5.3.2, they say, it is found that 25 cubic centimeters of CO2 is formed when one tablet completely reacts. Use the information in the graph and calculate the percentage CaCO3 in one tablet. So how do you calculate there the percentage CO2? That will be pure divided by impure times 100/1. So you remember we already have this percentage. Now the pure value I don't have yet, but impure I do have, because they say they have a certain tablet with a mass of 0,25 and it contains calcium carbonate, so that means that is your impure one, times 100/1. So how do I get the pure one? You will remember from the graph, they tell you use the information in the graph. So you will see this is pure calcium carbonate. And I must get 25 cubic centimeters. So I'm just going to draw a line. Let's make it a blue line. So when I get to 25, I must just draw my line there. So now I start from the left to my graph and from the graph downwards. And I get my answer of 0,1. So you see the previous one, we started at the bottom to the left, and now we start at the left to the bottom. So there I get my value, and I see it is 0,1. I put this in my calculator, and I get the answer of 40%. So that is percentage purity. I take pure divided by impure times 100 over 1. So that is very important. So I don't have to work out anything else. You will see it just counts 3 marks. So it's formula, substitution, answer. So if it just counts 3 marks, it's just formula, substitution, answer. If it counts more marks, then you have to do more calculations. So this one is just reading from the graph. 5.3.3, calculate the volume of hydrochloric acid that will be neutralized by 1 tablet. Okay, now I know this 1 tablet. 1 tablet was 0,25. It is found that 25 cubic centimeters of CO2 is formed from 1 tablet. So that means the mass of 1 tablet will be then 0,1. Because there's my 25 and the mass of the 1 tablet pure will be 0,1. So what I'm busy doing now, I'm saying N of CaCO3, that's my tablet, is small m divided by capital M. The small m is 0,1. I'm just going to make a note here. I'm going to write it from the graph. Divided by, I need the capital M of CaCO3. And this one is my favorite, you will see why. Ca is 40 plus C is 12 and 3 times 16. And if you get that answer, this one is precisely 100. So this one works beautiful when it's an easy number to work with. So this gives you 1 times 10 to the negative 3 mol. So now I have the amount of mol. But they asked the volume of hydrochloric acid. So I'm going to say CaCO3 to hydrochloric acid. The ratio will be, let's just get our formula. CaCO3, there's a 1. HCl, there's a 2. So CaCO3, there's a 1, HCl, there's a 2. So I take 1 times 10 to the negative 3 mol, and I times it by 2 divided by 1, so it will be 2 times 10 to the negative 3 mol. So now I have the amount of mol, so C equals N divided by V. 2 times 10 to the negative 3, and they say, they told me calculate the volume, and the concentration in the stomach is 0,1. Okay, now let's do some maths, because all of you don't understand the maths here. What I must do, I must multiply by V on both sides to get rid of the fraction. So I get 0,1 V equals 2 times 10 to the negative 3. And then to get V alone, I divide by 0,1 again on both sides. So a little bit of mathematics. So I first multiply by V to get V away there underneath. And then I divide it by 0,1 to get V on its own again. And then my answer is 0,02 cubic decimeters. Okay, boys and girls, you will see there's still a lot of calculations to do, but you can, we will send you also the document, and your teacher can also give you some of the answers. I just want to show you the following, that if you look at the ones that I selected, question 7 is for grade 12s. I put it in there, it is asset-based calculations, as well as question 8 is also for grade 12s. So you don't have to worry about that now, but just keep it until you get to grade 12. Then you will use this again to do some stoichiometry. And boys and girls, you must remember, stoichiometry doesn't end in grade 10 and 11. So in grade 10 you do stoichiometry. In grade 11 you do further stoichiometry. You go in a little bit deeper. And when you get to grade 12, we can combine it with all the chemistry. So you can determine, there's organic chemistry in grade 12s, maybe the amount of alcohol produced in hand sanitizer. You can calculate that, or the percentage purity of hand sanitizer these days. You're also going to calculate calculations concentration when you're busy doing chemical equilibrium. You're going to do a lot of stoichiometry when you do acid and base calculations. And then like question 8 that we have in front of us also is where you calculate the amount of metal on a bracelet. So it doesn't end in grade 11. So please make sure that you build your little science house on rock and not on the sand. When the storm comes, that is called a test and an exam, it will blow your house away when it is built on sand. So please make sure from grade 10 that you keep your notes, that you do all the calculations, that you do your homework every day to make sure your house is solidly built and that the grade 12 storm won't flatten it with the ground. So boys and girls, I hope you enjoyed this session and good luck with the exams.